Hello, this is Jennifer Martinez, and in this video we're going to investigate navigational problems using bearing with right triangles. What is bearing? Well, bearing refers to the direction of motion of an object, such as a ship or an airplane, or the direction of a second object at a distance relative to that ship or airplane. There are two methods for expressing the bearing. One is they always start with a north, and they draw an angle clockwise. So when a single angle is given, it is understood that the bearing is measured in a clockwise direction from due north. So the bearing of 32 degrees would be north, and you go 32. The bearing of 164 would be the same thing. So clockwise direction 164, we know that 180 is a straight line, so a little bit less than that. Or the bearing of 229 is a little more than 180, but less than 270. So again, they start north and they go in the clockwise position. So we know this would be 90. If I continue on, this would be 180. Continuing on, this would be another 90, which is 270. And then finally, up to 360 degrees is a full circle. So it makes sense that 304 would be between 270 and 360 in that second quadrant. So let's look at the distance between two ships. Two ships leave a port at the same time. The first ship sails on a bearing of 40 degrees. To find the bearing of another ship, there is something called a hand bearing compass, by the way, that you can use as long as you see the other ship on the horizon. So that's where they can get that. And it says that it sails at 18 knots. So 18 knots, what that means is nautical miles per hour. It's a rate that is used commonly in the seafarer's world. And there is a second ship on a bearing of 130 degrees at 26 knots. And the question is how far apart are they after 1.5 hours? So the first thing we need to do is sketch a graph to visualize this. Sketching a graph can be tricky sometimes, so let's go ahead and try this. I'm going to do a point here for the first ship. He's maybe right at that point A at the beginning, at some moment in time when he checks his bearing and he realizes he's about 40 degrees. Again, I start north and I go 40 degrees to this other ship. So the other ship has to be along this line here somewhere. I don't know where he is. Say he's right there at B. Maybe a little bit closer down, so that way my triangle is not so big up. Call that point B. And that second ship at that precise moment is north 130 degrees, so 180 is here. I'm going to guess maybe about right there. Hopefully that's good enough. Right, so as he's going 18 knots per hour, or nautical miles per hour, 18 knots, he's going to go in that line right there, following his initial position. So he's going to end up somewhere. So let's just say that instead, before the ship is, well, we still can call it B, but that's where he ends up. At the same time, this is going a little faster, 26 knots. He's going to end up at point C as he goes along that line. And the question are, after 1.5 hours, so assume that this is where that guy is at 1.5 hours, that is where that guy is at 1.5 hours. We're looking for the distance here between those two ships. Now, this can only be solved in this section if we have a 90-degree angle. So hopefully we have a 90-degree angle somewhere. So let's go ahead and investigate that. As you can see, that's not given in the problem. In fact, many times the direct information that you need for a problem is not stated and only can be determined from a sketch. Okay, so what do we have here? I know these are both north. Those are both due north. Let me write down north there. I never did that. So they have to be parallel. This is a transversal line through two parallel lines. So this one and this one have to be the same. So that has to be 40 degrees also. Okay. That's only part of that angle. So we know this whole thing from there to there, that's a straight line, so that's 180. So this angle right here has to be 180 minus 130, which is 50 degrees. Great. That one looked like our 90 degrees, and we just proved indeed it was. So my picture is getting a little crowded there. So I'm just redrew it over here, ABC, try to get as close as I could, and we now know that that's 90 degrees. That's all we have so far. But we're looking for this. We know what this is, across from A. We'll call this across from B. We'll call that C. We could call this little b, but I already labeled it X, so that's fine. That's what we're looking for. So we know what A and C are because C, for instance, that is that first ship. So he was going at 18 knots, and that was per hour. And they want to know, if they said 1 hour, that would have been so much easier, but they said at 1.5 hours. So if we take this and multiply it by 1.5, you would get how far he is in nautical miles. So again, 18 nautical miles per hour. I guess you could just say per hour there. Times 1.5 hours is 27 nautical miles. We can do the same thing for the A. We know that A is 26 times the 1.5. The same logic here. And so you would get nautical miles. So we know that C is 27. We know that A is 39. And we can actually, don't even have a right triangle with two sides. We could use the Pythagorean theorem here, can't we? So we could say that the A squared plus C squared equals the X squared, since that's a hypotenuse. I know we usually call C very bad labeling, actually, because we usually call C a cross, but we didn't know that at the time, at least I didn't. So we have 39 squared plus 27 squared equals X squared, and we can solve for X. So if you add these up on your calculator, the left side you get 2,250, then take the square root of both sides, and you get about 47 nautical miles. Okay. There's another way of expressing the bearing, and that's using a north-south line, not just a north line. But then they would always let you know which direction. So if they don't have any words other than bearing, you know it's north. But if you see this notation or this notation, then you know it's different. Starting with the north-south line, we're going to use an acute angle. We're not going to have obtuse angles. With the first one, we did have obtuse angles to show the direction, whether east or west. So you can have, this one actually, you could have just said bearing of 42, couldn't you, of either way. So, but it's north 42 east, which is a bearing of 42. But on this one, that's not the case. You can go north 52 west is the example here. Or you can start south, which is these two middle ones, to south 32 east. So what I think of is my north, south, west, east direction. And here we're going to go south 31 degrees in the east direction, and this would be south 40 degrees in the west direction. So let's look at an example about flying distances. On this example, it says the bearing from A to C, okay, now they're going to label, so that's good, is south 52 degrees east. So let me do that first before I do anything else. Again, it's really important to sketch the graph here, so I'm just going to do any label A there. And it says the bearing is south, so now I'm going to go south instead of north I'm going to go 52 degrees in the east direction, which is this direction. I know that that's 52 degrees. And that is where somewhere along this line is where C is. So I'll label that C. Not going to be exactly sure until I do the rest. So let's check it out. The bearing from A to B. So we have, again, from A, again, is now north. So now I'm going to go back to north. Oh, in the east direction, we're used to that. Almost 90 degrees. Almost 90 degrees there. And that is going to be from A to B. So B is going to be somewhere along this line. I'm not exactly sure where. I'm going to guess maybe about right there. Then finally, we have to get to B to C. We got to make this work. The bearing from B to C is south 38 degrees in the west position. So maybe something like that. I don't know. 38 degrees, right? Less than 45. That's going to be 38 degrees right there. This one I forgot to write. 84 degrees there. Uh-oh. So C has to fit that. So I was way off on C, you can see. So I'm going to put my C a little higher up. And that should work. There is my sketch. Sloppy as it is. Okay. So now we need to use our trigonometry to find the angles inside, because all those are angles outside. So I like that A angle, and hopefully again one of these is 90, but I like that A angle because we know the whole thing is 180 right there. So if I take 180 minus the addition of 84 plus 52, I should be able to find the angle A. So you get 180 minus 136, which is 44 degrees. So we know that the A is 44 degrees here. Okay, what next? I can do the same idea as I did up above and draw a vertical line here because I know all these are vertical lines. So that's where the parallel is. So I know that this one is 52 degrees because they're alternate interior. And the same thing over here, must be parallel lines even though they don't look like it. This is 38 degrees. So I know angle C is 52 plus 38, which is indeed 90 degrees. Yay, we have a 90-degree angle. Okay, let's stop there and maybe redraw this. So I so far found that this is a 90 degree, so I'll just put that there, and I found that A was 44 degrees. Okay, let's read on. A plane flying at 250 miles per hour takes 2.4 hours to go from A to B. Find the distance from A to C. So this is the distance we want to find. And AB, they're given us. So what is AB? AB is a distance, and we know distance is rate times time. And the rate is 250 miles, I'll do it that way this time, times 2.4. But you can see that the units do work out because this is miles per hour, multiplying by hours, and they do cancel. So what is that going to be? 600 miles. So we know that is 600 there. So I'm done. I'm ready to use my trig. This time we have an angle and two sides. So this is the adjacent, and here is the hypotenuse. I know it's kind of weird because it's in a weird position, but it's across from the 90 degrees, so it's the hypotenuse. Adjacent over hypotenuse, what is that? Cosine. So I'm going to use that 44 degrees. Cosine is the adjacent, which is the x, over the hypotenuse, which is the 600. By the way, you could have also used secant and flipped it. But if I multiply both sides by 600, I'm going to get the answer. So plugging this into your calculator, making sure you're in degrees, you get about 431.6. But since they only use two significant digits, I'm just going to say about 430 miles and round to the nearest 10. Hope this helps.